Yeah, morning. I'm G. Vinod Kumar and I'm teaching you the question number 14, which is titled as Split Array Largest Sum as per lead code and given an array. And let me tell you the easiest way that how I learn this question, the best approach that I'm going to teach you now. So they'll usually give an nums array and m equals k equals or m. They'll usually specify it's actually k equals to some value. So what k actually represents means suppose assume that k equals to how they actually give k equals to 2, right? K equals to 2. So it means the whole array should be split into two valid parts such that the result should be minimized from the maximum sum. So that is the reason largest sum they have mentioned. From the largest sum, you need to get the minimized value. So maximum minimum. This is a variation of the maximal minimum. And you need to split, you can at most you can split into the k equals to two parts. You can't split more than that. If you split that, it can't be the result. It can't get you the result. So it should actually split into up to two parts only. So let me teach you what is the right intuition that I followed to this question. So assume that these are actually boxes of chocolates, and k equals to 2 actually representing that the children's those who can share the box of chocolates, which is usually an array. So the k students gonna share the array of chocolates such that we will get the minimum value from the maximum. So from all the maximums, you need to obtain the minimum. You need to get the minimum. So first, this is actually a binary search approach way of solving this question. So you know the binary search approach, right? You just actually calculate submit and then you'll write the while condition. Within the while condition, you will calculate the mid and you'll check. It's actually a simple thing where you'll check if here we don't need actually the return case, that kind of thing, because we actually need to return an index variable where it actually the correct position that we can split the array. So that is the index that we actually need to, that is the answer we actually need to return. The answer is nothing but the index. So this is the array, right? So we need to return an answer variable which actually contains an index which represents the correct spot you can split the array into k pieces, k parts. So first, binary search. It can be only applied on a sorted array. But here it is actually not sort, but you can consider that at most k students are there, right? At most, what is the maximum chocolates can he share? It means what I'm trying to explain you is, as I told you previously, this array is nothing but a boxes of chocolates and k is nothing but the students, those who share the array, which are actually chocolates, those who share the chocolates among them. So even if they share, if even if he takes the maximum chocolates, the ones first student, it can't exceed more than, right? Because the existing chocolates are only within the array. You can't take more than that. You just limited to all these parts. But usually we don't take this many chocolates. But we don't need to allocate that many chocolates to a single student. We need to allocate it to students where we'll finally get the minimum number of chocolates for each one. At the maximum point, you will get the minimum one, minimum chocolates. Yeah. So, wait. Yeah, I'm getting it. Yes. So k equals to 2, and this is my array. And you know how, yeah, we stopped at getting the search space, right? So as I told you, this is a search space, and the search space is not sorted, so you can't apply binary search on directly the array. But as I told you that at max it can't reach sum of elements, sum of boxes of chocolates, sum of number of chocolates. So it means if you sum these total elements of array, what it could be 10 plus 8, 18, 20, 27, 32. It's 32, right? At max, you can't exceed more than 32 because those are the chocolates. You can't exceed that 20, yes, 32. So we found that a value, we can't exceed that value. Our count can't exceed, our search space can't exceed that value. So our final highest extremely endpoint was fixed, which is actually 32. So we can determine, we can use the for loop and add first all these values and count as 32, which is high. And the lowest point it can be is every student want to get shared, right? So it's actually 0, no equals to 0, because at the lowest point, the first student, the fat guy, who can take all the chocolates, but then second student can't have any chocolates, right? So it's the worst case for him that he could have 0 chocolates. So the subspace is going to be 0 at max in both cases, in both students, even if the number one takes or if the number two takes all the chocolates. This is going to be the worst case if you see both the cases where one actually takes all the chocolates, the other one results in the into the 0 number of chocolates. So a subspace is fixed and this is a subspace and this is, and here we actually do the binary search. And yeah, typically binary search is nothing but low plus high by 2. So what we'll actually get a midpoint. So what is the midpoint for this one? 0 plus 32 by 2 equals to, yeah, 16. So mid equals to 16, right? So using this value, listen here, we're not actually putting the binary search on the given array. We are actually created our own search space and there we are actually putting that, and with the value of the middle, we are actually performing a operation, and I will tell you that how we are doing that. And so you are able to understand how I'm actually applying the binary search not on the arrays but on the range that I'm extracted from the question that they have given by using the concept that students and chocolates are being distributed by them. So you actually have a value 16. So currently what is actually fixed? Your search space was fixed and you need to find the maximum number where finally you need to get the minimum of that. So with the 16 as made, at most, sorry, at least you need to assign the student as this many number of chocolates, 16 chocolates. It means you need to pass a function to a function that 16. So what it says is actually can 16 be splitted between two students, those students, maximum allowed chocolates are 16 here. So students can't exceed that many number of chocolates. They can take up to their part 16, but they can't exceed that part. It means students are two actually. Student one can take 16 or below 16. He can't exceed 17. He can't exceed taking 16, which comes 17, 18. He can't take them. He just only allowed to take 16 pieces of chocolates. And same for student 2 and k equals to 2 representing that. So this value is passed to a function and the functions work is nothing but it will receive a value and its return type is actually a boolean. It tells that by taking a value, a middle value, which is in this function, it is actually says as maximum allowed, because as I told you that these you can't exceed taking this more than this number of chocolates. You can take up to this number of chocolates, which is I'm passing to it, and the variable name is max allowed. So maximum number of chocolates that I'm allowing is passed as to the function by the main function that we actually started writing the code, and we actually pass that the mid is nothing but 16, so 16 is being passed as max allowed chocolates, and here max allowed chocolates equals to 16. So you can't exceed taking more than 16. You can take up to 16. How many number of students they can take up to the 16, and based on that, if the students actually exceed, you need to return false. if they actually correctly took those chocolates, then we should actually return true. So okay, don't get overwhelmed, focus on the current. So I'm actually getting 16. What I need to return is either true or false. Can I actually split? Is that actually valid that I can make the students take 16 chocolates, each 16 chocolates? If he actually implements the student more students, then what's the case? False, because you can't exceed taking more than, not about chocolates, it's about the number of students. K given as 2. You can't exceed more than 2 students, you can take up to 2 students. So we actually need to create some 2 variables, and this function is valid is the name of the function, and its return type is boolean. And yeah, I don't know what to keep. Okay, so this is the this is the maximum which is actually passed within the parentheses. 16 as passed, and it's named as maximum allowed chocolates. And here we need to create some variables, 2 variables. One is maximum allowed chocolates is actually being passed, that's the different thing, but we actually need to say number of students. So we actually need to count the number of students, because that's a key thing. If you exceed the number of students value greater than k, then number of students. And what is the other variable that we can keep? Yeah, first tell me the function of, you can't exceed this number of students more than k. You can do up to equals to k, but you can't exceed number of students actually greater than equals to k. You can't do that because they actually gave you k equals to some value. It is actually fixed. You can't do more than that. If you do that, you're gonna return false. And then, so usually we start it with the 1 and chocolates. You have a variable named chocolates. Chocolates that are assigned for student 1 is initially 0, and you will check whether the conditions that, if here you will write a for loop, and num is the not index, it's actually the element that is in the array. If num value is actually greater than maximum allowed, which is actually in this case 16, if this is the case, what it actually means, if the first element only exceeding the maximum allowed, then it is definitely going to be false. But it never happens because, sorry, it's actually not a for loop, it's actually an if condition. After this, wait a minute, no, the condition is actually true, but the for loop comes, I guess, yeah, for loop comes above, and with what's the condition for for loop? Yeah, we travel. I don't need to write this all stuff, blah blah blah. And let me erase this stuff. Yeah. So in this for loop, first I'll have a condition that without, you can do that afterwards also. In the for loop, we are actually using num, num. I can't write here, but if num value is greater than the maximum allowed one, which is actually 16. Wait a minute, I can write directly 16. But I need to actually care about those values. I'm sticking to the same example. No need to worry that, and you need to return false. Yeah, you need to return false, or else if that's not the case, it means if nums value is actually less than 16. Yeah, if, and you can have the another condition, if the current element plus chocolates value is less than the 16, then you need to add that into the then you need to actually what it actually means. It means the student can take the chocolates. It means the number which is in this case it is actually 7. In the array you can see that it's actually 7. You can take the 7 here, 7 plus chocolates, which is actually 0. So 7 is less than 16. That's actually true. It means the student is able to take the chocolates. The student number 1 actually able to take the chocolates. So we can allow him to take the chocolates. And again, you need to do the same steps. But when it actually happens, that as I told you before, if it actually exceeds, if the student actually takes more than 16, like 17, then you actually need to return false, because he can't actually, he won't take, because you are actually handling him to not take. So when we take 7 plus 0, it's actually less than 6. Okay, that's true. And you wanna add that into your answer, right? So what we'll do, chocolates equals to chocolates equals to this part comes here. And do you need to do anything? No, you don't need to do anything. You just successfully did this one. And this is the syntax of Python. I haven't used this curly braces here. Yeah, no problem. So this is a case where a student can take chocolates because he haven't exceeded his maximum allowed chocolates, so he can take up to here. But in the else case, what it actually means is, in the else case, what it actually means, if nums plus chocolates value is greater than 17, then it is going to be else. So you don't need to actually write the case further. So you can directly put the else condition, and here what you need to do is you actually need to make the chocolates equals to 0. So you are actually restarting the pointer, and also number of students actually incremented. It means here it's actually plus 1. It means you are incrementing number of students, because this else block, when it will actually hit, you tell when 16 value is less than or equals to 16, that's actually condition true, because he can able to take 16 number of chocolates. But if he takes 17 chocolates, then we won't execute the if, and we can directly jump into the else case. And there what you actually need to do is, the student, you can say confidently that number 1 has took his part, and it's time for numbers 2 student, that he can start taking his chocolates. So let's reset all the pointers for number 2. So let's reset the pointers that we have used for number 1 to number 2. So chocolates equals to 0 and num plus 1, which actually representing is, it's actually number of students. This is, and this is actually different. And number plus equals to 1 means the students have been incremented. So it's actually 2 currently. Number equals to number of students equals to 2. So after completing the else block, you will go again and you will do the same stuff usually here. And if that is the case, then right. So after completing the whole stuff, what it actually happens means, you just add up to all these values. First, is it less than equals to, is it num value plus chocolates less than equals to 16? So add it. So again, you will do this repetitively up to you reach 16. Your sum is actually 16. So let's count. 7 plus 2, 9. 9 plus 5. What is 9 plus 5? 14. So up to 14 is actually perfect, because 14 is less than 16. But when comes here, again you will come from here, and the num is actually 10, and plus chocolates is actually 14. So 10 plus 14 equals to 24. 24 less than 16, is that true? No. So go to the else block, and it's number 1 became happy, and we shouldn't give him the chocolates, and we should switch to the number 2 students. So we will go to the else block, and we will make the chocolates for number 2 student 0, because we haven't assigned up to now. We need to actually assign those chocolates now. Yeah, we need to assign those chocolates. Here we can't keep 0. We should keep here num. It's not number, it's actually num. num is in this case actually representing 10, not in this case it's actually 10, because up to this part we actually assign to the student 1, and this part is going to be student 2. If he exceeds, he can also take, if any value present here, there is a chance of taking student 3 also, but we don't allow them. If he takes the number 3 student come and takes, we need to actually return a false statement. So here number 2 starts taking the 10 number of chocolates in the else block. So chocolates equals to 10 for number 2. So chocolates equals to 10. It became from 14 to, it's actually completed, right? So we won't actually do this block at this when num equals to 10. So you'll enter the else block where chocolates equals to num. You're not adding it, you are actually assigning it. So chocolates equals to 10 and num plus 1 equals num plus equals to 1. It means number of students actually incremented and number of current student is actually 2. So at the next iteration, num is equals to being 8. So 10 plus 8 is equals to 18. 18 value is greater than 16. Is that true? Yes, that's true. So wait a minute. Nah, you can't do that. No, no. It's actually 10, right? And you are coming from here, you check the 10 greater than equals to 16. That's not true. So nums plus chocolates. Nums is actually in this case 8 plus 10 is less than 16. So chocolates is being currently for him. What is the chocolates for him? 18, right? Wait a minute. Is this is not going to be executed because 18 is greater than 16. So you don't execute the if and you go to the else, and what it actually means, yeah, we have actually given two students and those two students have taken the chocolates without exceeding the maximum amount of chocolates, because we are here, we are actually exceeding the number of chocolates because 18 is actually greater than 16. If you can't take that many chocolates and you can't split the box of chocolates which is 8, you can't split them and give it to the number two student. You can't do that. You need to either give the whole box of chocolates to the student two, or else you can quit giving the chocolates for student two. So that's the actual rule. So here you can't add it to the chocolates. So it's being 10. And when you come here, chocolates equals num. Currently, what is num? Actually, it's 8. So it said for a new student, we are assigning it for a new student, and new student value plus equals to 1. It means 2 plus 1 equals to 3. Previously it was 2 because we have done up to that iteration, but here it became 3. And here comes up into the picture that we have completed the iteration of the array. It is completed, and here will have a condition that if number of students value is actually greater than k, it means students value that we have given 2, but you took another student and gave him chocolates. You can't do that. You are supposed to do only the pro up to the provided students only. You can't do that. So we will return false. So when we return false for the binary search thing, I think I can show you on the code. That's way more helpful now because you actually understood what I'm trying to say now. Here, 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 this actually hit it because number of students is actually in this case number of students is 3, and which is actually greater than k, so it's actually true. So we'll hit the false and return it here, and here we don't allow that. So you actually, it means you can't allow the student to take that many number of chocolates. I mean, with the mid as 16, which is maximum allowed chocolates, you can't actually tell him to, you can't actually divide into the, you can't actually divide the students with k. So you need to change your pointer, midpoint. So it's actually false. So you don't actually execute this one. You'll go to the else block and left equals to mid plus 1. So left became 17. Mid plus 1 is nothing but 17. So 17 and 32 is a subspace, and you'll do the same thing for up to some time, and when it's the time when the students can actually pick the equal number of with an index as made, maximum chocolates allowed. If the two take correctly, then we will return here true. We will return here true. When it will actually happens is if number of students value is not greater than k, then we'll hit this one because with the students you have actually split the chocolates, whole chocolates perfectly. So we don't need to bother about that, and will return true. And in that case, this will be executed and answer equals to being made. It means you currently have an answer, but this is not the final answer. We can find a better answer with the minimum one. Here we actually aimed for the maximum and we took that and we keep it aside. And then you are going for the search space as right equals to mid minus one. You are going towards left because your search space is sorted, and you're moving towards left means you are decreasing it. It means it actually shows the drive that how we are actually going towards left to reach the minimum value, minimum sum. So that is what actually we want, right? Split array largest sum. From the largest sum, you are actually getting to the minimum value at the end.